Hey, what's up guys, welcome back to Eureka, and in this video we'll be covering the material for the mechanics periodic in week 7. Now, they didn't post the revision sheet on web school yet, so what I'm going to do is I'm going to go through the book, okay? I will try to find the basic questions or the questions that I think are hard, and I'll explain. So, let's start. We have example 1.1 page 3. I'll do B. Okay? So, they gave us two vectors. P like this, right? This is vector P and then Q is like that. Right? They said they want to find P minus Q. Now, we know what's P plus Q. We learned vector addition before, right? But what's subtraction? Subtraction is just the inverse of addition, right? So this is Q right here. Negative Q is the same thing. It's just flipped. Same magnitude, opposite direction. This is negative Q, right? So we can express P minus Q as P plus negative Q. And you know how to add things together. We have P like this and negative Q like that, right? When we add those two together, we'll get this vector, which is P minus Q. And that's your answer. Moving on, we have example 1.2, page 4, and I'll do C. Okay, so they gave us F1, it's a vector, right, is equal to 2 and 3 newtons, object newtons, and then F2 is equal to 3 minus 2 newtons, right? Now, this notation is kind of weird, so I'll rewrite it like 2I plus 3j newtons, and this is, so this F1, right? And F2 is equal to 3I minus 2j newtons. And part C, they asked us to find 4 times F1 minus 3 times F2. So what's 4F1? We multiply F1 by 4, right? So we have 4 times, what's F1? We have 2I plus 3j, and then minus 3 times F2, right? So 3 times 3I minus 2j. We distribute, we have 8I plus 12j minus 9I plus 6j. And then we group the i's and j's together. We have negative I plus 18j. Now, because they gave us in this column notation, it's good to write it out as a column notation as well. So we have F1 plus F2, 4F1 minus 3F2, there should be an arrow here, is equal to negative 118 newtons. And that's your answer. Example 1.3, page 5. Given that A is a point, so 2 centimeters, negative 4 centimeters, and the vector AB is given in column notation as well, so we have 7 and negative 9 centimeters. This is negative 9. Okay, we need to find, sorry, I'm missing C, so I have point C as 5 centimeters and 0. They said find BC. Okay, so we're given a point A. Now that's not really helpful because we want things in vectors, right? So we need to find the position vector OA, right? This is equivalent to A, being that instead of 2 centimeters and 4 negative 4 centimeters, we have 2 and negative 4 in column notation. Okay, so this is OA, and then we have same thing with OC. This is 5 and 0. Now, they want us to find BC. So we know that AC is equal to AB plus BC, right? Solving for BC, we have BC is equal to AC minus AB. What's AC? AC is equal to OC minus OA. So AC is equal to OC minus OA. That means we have OA plus AC is equal to OC, right? And this is quite obviously true. We have point OAC. This is OA, that's AC, so the sum will be OC. Anyways, moving on. So we have BC is equal to that. This is AC. minus AB, right? What's OC? OC is 50. So this is 50 minus OA is 2 negative 4 minus what's AB? AB is 7 negative 9, right? Let's do this step by step. So we have 3 4 minus 7 negative 9. So this is equal to minus 4. 4 plus 9 is 13. So that is your answer. This is BC. This is in centimeters. Next up, we have example 1.4, page 7. A force is given by, so a force F is equal to 6I minus 8J newtons. What is the magnitude of this force? Find its unit vector. Represent the answer as the product of a unit vector and the magnitude of F. So that's a mouthful. Let's break it down. So first things first, magnitude. This is the easiest. We have 6 squared plus negative 8 squared. This is equal to 10, right? So the magnitude of F is 10 newtons. Find its unit vector. So we know that the unit vector F, right, is equal to the vector F divided by its magnitude. So that means we have 6i minus 8j over 10, right? And notice that the force is in newtons and 10 is in newtons as well, so they cancel out. Anyways, we have 3 over 5i minus 4 over 5j. This is the unit vector. Notice that it is dimensionless. Now, the last part, they ask us to represent the answer as the product of a unit vector and the magnitude of F. So, what we need to find is the force is equal to the product of the unit vector times the magnitude of F, right? We found them both. So we have 3 over 5i minus 4 over 5j times the magnitude is 10 newtons, right? So we have 10 into 3 over 5 is 0.6 I minus 0.8 J newtons, and we're done. Moving on, example 1.6. I'll do A, B, and E. Okay, so A, we have 0.44. We need to find the magnitude of R and the direction of theta, right? And they're all position vectors. So this is a point, right? But we can represent this as a position vector. We have 4i plus 4j, right? What's its magnitude? The magnitude, R, is equal to the square root of 4 squared plus 4 squared. Let's see, this is equal to radical 32, which is equal to 4 radical 2. So that's the magnitude. What's the direction, theta, right? Notice we don't even need to make any calculations here. We can just picture this. 4, 4 means you 4 to the right, so you move 4 to the right and 4 up, right? That is your vector. Now, this is an angle bisector. We know that this angle will be 45 degrees, right? Since it's moving the same amount to the right and same amount upwards. So the theta, in this case, theta is 45 degrees. Part B. B, we have the point negative 3, 4 or negative 3i plus 4j. This is a 3, 4, 5 triangle because the length is 3 and 4, so the hypotenuse is 5. So that means the magnitude is 5. You can verify this by, well, negative 3 squared plus 4 squared. You'll get 5. Now, the angle. So theta, because we have x is negative, we have a negative x. We have to write, if it's negative, write 180 degrees plus the tangent inverse of y over x. So we have 4 over negative 3. If it's not negative, like 3i plus 4j, the theta will just be without the 180. So it'll just be tan inverse of 4 over 3. Okay? This will give you 180 minus 53 about. So this is equal to 127 degrees. So that's theta. Now, part E. We have 0, -4, right? We don't need to calculate anything in this case. The magnitude is 4 because all it's doing is moving 4 downwards, right? So the length is 4. Now, what's theta? Theta is, if I draw my axis over here, that's way too thin. That's my axis, right? The angle from the positive x-axis is like this. So theta is 270 degrees. Okay, moving on, we have example 1.11, page 14. This is the hard one, okay? So find the vector equation of a line that passes through the point M, whose position vector is given by M. So that's where it passes through, okay? So M vector is equal to 3i plus 4j, right? So it passes through this point and it's parallel to another vector v is equal to I minus 2j. And we need to find the vector equation of a line. So a line is y is equal to mx plus b, right? In this case, you're trying to find the position vector, right? We're trying to find r. This is equal to, so what's m? It's the parallel, right? The slope is like its direction. So if we say that two vectors are parallel, they have the same direction, right? So m is v in this case. It's the direction vector. So it's equal to I minus 2j, right? You have an x, but I'll write t. It's the same thing, just different variables. And then plus b. B is where it passes through, okay? So it's plus 3i plus 4j. In general, though, it's r is equal to the direction, which is d, t, plus where it intersects. I don't know what to call it. Some random vector a. Okay, d is a vector as well. This is the general formula. Anyways, we distribute the t, so we have ti minus 2tj plus 3i plus 4j. Group the i's and j's together, so we have 3 plus t. This is I. Sorry, 3 plus t. And then we have plus a 4 minus 2t. And then we have a j. This is 2t over here. So that is your vector equation of a line. Moving on, we have example 1.14, page 16. Find the dot product between the vectors a and b, where a is equal to 3i, and then we have b is equal to 3i plus 2j. Okay, we can do this in two ways, either the easy way or the hard way. So we have the vector a dot vector b. This is equal to a sub x times b sub x plus a sub y times b sub y. What's a sub x? It's 3. What's b sub x? It is 3. Plus a sub y is 0 times b sub y is 2. That cancels out, so it's 9. Okay, that's the easy way. The hard way is we do a dot b is equal to the magnitude of a. I'll just write it like this. So we have a times b times cosine of the angle between them. So let's graph this. So we have, that's not a straight line. Okay, we have, let's see, this is a, right? It's 3i. And then we have b something like this. I don't know. Okay, we need to find the angle. So this is theta. Now, how do you find theta? We know that cosine of theta is equal to adjacent over hypotenuse, right? Which is 3 over, what's the length of the hypotenuse? It is the magnitude of b, right? So we have 3 squared plus 2 squared. This is equal to 3 over 9 plus 4 is 13, so we have radical 13. So that means we have theta is equal to the inverse cosine of 3 over radical 13. You can compute that in calculator. So substituting everything here, we have a, the magnitude of a is equal to 3, right? Magnitude of b is equal to radical 13. And actually, you don't even need a step. You don't need that. This is cosine. So we have cosine theta equals to that, right? Just plug in right in. So we have, this is equal to 3 into, over radical 13. They cancel out. This is equal to 9. So easy way or hard way, it's your choice. Now, one note, okay? If they ask you to prove that two vectors are perpendicular or orthogonal, just do their dot products, okay? If their dot products turn out to be 0, then they're perpendicular or orthogonal, okay? Okay, so I think we're done with vectors. As I said, I already made 8 videos on vectors already, so and I explained them in depth, like each topic I made a video on it. So just check them out if you want to like actually like understand what's going on instead of just plugging in formulas like that. I actually like proved this relationship over here, which is pretty amazing. Anyways, I'll end this video over here. In the next one, I'll do chapter 2, hopefully finish it. It's a long chapter. We have, let's see, we have 16 sections. But it should be fine.